Hello everyone. I know it is a weird topic, right? So we have been talking about machine learning algorithms, but all of a sudden we switch to algorithms, and I will tell you why. Okay? So today's topic is greedy algorithm. So for a greedy algorithm, as the name says, we are just making greedy choices. So usually a greedy algorithm has a multiple rungs or multiple steps, and for each of the step, we don't want to look anything further down the path. We just want to stay on the current situation and the current status, and then we are making a greedy choice. And after that, we may move on to the next status. And then on the next status, and again, we make a greedy choice and we just keep on going. And the hope is by making a greedy choice on each step, and eventually we are gonna arrive to a optimal solution. So you may ask, is that possible? Is that always true? To be honest, it's not. Well, but for greedy algorithm, sometimes people do code greedy algorithm and people do make greedy choices. And there are several reasons, especially for the greedy algorithms. So number one, the greedy algorithm is fairly easy to design, and it's also fairly easy to code. And another thing is, if you have a greedy algorithm, analyzing the greedy algorithm is also a easy task. So if you have a greedy algorithm, and you can easily find the time complexity of that algorithm. However, for the greedy algorithm, sometimes it doesn't really give you the optimal solution. And if you want to justify that your greedy algorithm is indeed the optimal solution, this justification can be hard too. Okay, so that's the introduction about the greedy algorithm. Excuse me. And we are going to see an example. So let's assume that we have a very busy student and her name is Alice. Well, and she only has that many of the hours and she wants to work on some of the assignment questions. So this might be true because for some of the assignment questions, they can be so hard or they take much longer than some of the other homework assignment questions. So, Alice decides that she wants to work on the task which takes less time and try to maximize the number of the questions she's able to answer. Okay, so you will have an array A, and that will be a array of the integers, and for each of the number, it represents how many hours that Alice has to spend in order to solve that question. And in addition, you will have another parameter t. So for the parameter t, that will be how many hours that Alice has. Okay, so in this case, she's going to use t hours to solve some number of the questions in the array. And then for each of the question, and we will have a number of how many hours it is needed to solve that question. So, if we want to do this, if you want to do this uh, program, one of the things we can do first is we take the A and then we just sort it. We sort that from low to high. The reason is, if we only have limited hours and we don't have the time to do all the questions, say if we only have 5 hours. So if we have 5 hours, if we take the first question, which takes 1 hour, the second question another 1 hour, and then the third question 2 hours. Okay, so within five hours, or actually within 4 hours, we can solve three questions. So that's the best we can do. However, if you spend 5 hours to solve just this question, or just the first question in the unsorted list. You spend a full of 5 hours and then you only got one question solved. Okay, so to make a greedy choice, well, it is quite clear that we should start from the lowest number and then try to solve that question first and then move on to the next question. So this is how we can better utilize the hours we have to solve the most number of the questions, right? So this will be my algorithm, and feel free to take a look on my algorithm. And then let's assume that if we have a total of 10 hours, so we are going to sort the list first, and so this is sort. And after that, well, we want to pick the smallest one, and then the second smallest one, the third smallest one. We add them together until the sum is greater than 10, and then we want to stop, right? So we pick 1, 2, and 5, that the sum will be 9 at this time. If we want to do the last one, which is 8, and then it will exceed the total hours we have, which is 10. So we want to pause there and we solve 4 questions. And if we have 100 hours, and that is more than enough, so we are going to solve everything. Well, if we have 0 hours, so we don't want to study at all, and then the number of the questions we are going to solve will be a 0 for sure. Okay, so here's the discussion part. Well, does this algorithm always produce the optimal solution? We do have to think about this. So in this case, the answer is yes. Okay, and then the next one. Well, what is the time complexity if the A is unsorted? So we want to take a look at this algorithm. So this is a primitive step, this is a primitive step. Both of them take constant time. And then this sort. Remember, a sort is a n log n. And after that, we do an iteration. So we are going to do that for a total of n rounds. And then there's nothing special there, and then we return. So this is constant time, a constant time, and we have a n log n, and then this iteration takes O n time. So we pick the highest one, and then the time complexity is n log n. Okay, and the last part, what is the time complexity of the if the A is sorted? So if the A is already sorted, and then we can save this part. We don't need this part anymore. And in this case, this is a constant time, this is a constant time, and then this is the O n. So if we don't need to sort that, and then the time complexity can be reduced to O n. So that's my answer. So I'm going to show you my answers again. So the first one, it is indeed a optimal solution in this case. Well, I cannot think about any case that we don't have a optimal solution using this code. Okay, and then O log n, because we have to sort that, and if we want to save the sort, and it's become the O n. Okay, so the point is, if we have a greedy algorithm, and analyzing this algorithm is kind of easy. So the next part, this is an exercise for you. Okay, so if we have a number pyramid, and on this number pyramid, we want to trace from the root down to the bottom, and then we want to have the maximum of the sum of the number you have visited from the top to the bottom. So for example, if we want to trace from 3 to 7, and then to 4, and then to 9, and then you will get the maximum, and the maximum is a 33. So how do you do that? Well, if you start from the top 3, and then you have 2 directions to go, right? From 3 you can go either to 7 or 4, and if you want to pick a greedy choice, and you should pick the higher one, because our target is we want to get the the highest sum of all the numbers we have visited. So from 3, you want to go to 7. And at the 7, you want to make a greedy choice again because underneath 7, we have 2 and 4. And then we pick the higher number, we go to the 4, and then 9. Right? Okay, so just move on and try to code this. Try to write the code for this one. Okay. Wait. So it seems that I have already given you the solution. Okay, so anyhow, well, this is the solution of this algorithm. So we just go down, and then for each of the index, we can go down to different directions, and then we pick a greedy choice. So okay, so I think this is the discussion part. What is the time complexity of this greedy solution, and does this always give you the optimal solution? So think about that, and I will see you in the next video.